So how you doing? Here we have a Mimosa B11 Backhaul radio. These are used by wireless internet service providers in remote locations to beam internet from one location to another, up to about, I'd say, somewhere around 20 kilometers or so. So here in the west of Ireland, these are quite common. As fibre gets rolled out, they're less and less common. I'll just turn the crosshair off for now. Yeah, you kind of, over time, we won't see them as much. So the number here, this is just for my own repair log, and this is a little note left in permanent marker by the client to let me know what's wrong with it. Now, to get into these things, we need some heavier hardware than your normal laptop repair and stuff like that. So I have a couple of these, and we're just going to check them for size. You'll always require gear like this in remote locations, but as the fibre network expands, it just doesn't really make much sense. So I fixed a few of these. They're usually one or more of the ports gets frazzled either by a power surge or by lightning. The lightning is always an interesting one because PCBs will actually boil off. Might throw in some clips here of a PCB that the layers have delaminated, and you can actually see the ground planes start to bubble in them. Yeah, it's quite impressive. But yeah, I fixed a few of these B11s. Usually it's just port damage. There might be like a transient voltage suppression diode on the port as well that goes, and I'm hoping this is just as easy as that. So there we go. That's the kind of first hardest bit. What you will notice is the kind of salt build-up. This is normal in the west of Ireland. Even in summer we were in around 98% humidity, and the air is thick with salt, especially in winter. So yeah, it causes absolute havoc on anything up a mast, or I fix stuff on like GPS stuff on boats and things like that. Same problem, salt will just get in everywhere. So Denso tape, grease, all this kind of stuff to try and keep out the kind of ingress of humidity and salt. Okay. So we need to disconnect the some gunk here. Disconnect these LEDs. Just a little LED panel. Okay, before I get in and release the board, I'm just going to have a quick look. Yeah, there seems to be something going on down here. Yeah, we'll have to figure out what happened there. So this is our Wi-Fi module. You'd use this for configuration and stuff like that. I'll probably have to blur out some of the serial numbers on this board and stuff, just because they're such low volume number, and the licenses are linked to the actual units themselves, so I wouldn't want anyone stealing the licenses. But what's very important is all these little rubber gaskets. We need those. They're vital for keeping this thing protected from the weather. Can't lose any of those. But again, you'll kind of notice that there's that white crap on everything. Again, that's just salt and ingress from moisture. So I'm going to remove this main gasket. A little tip for when you're putting these back on, you can use a little bit of Vaseline or oil just to make them, because they sometimes when you remove them they don't want to go back the way they came off. What can be a good idea as well is before you start removing these screws, is if it's your first time working on one of these units especially, is either do a little kind of outline drawing of this and make a little screw map that you can pop these through the paper so you know exactly where they're going to go. But what I'm going to do is I'm going to back them all the way out, lift the entire thing, and just put tape over the tops of them to keep them in this kind of heat sink so that we don't lose it. So also, before we go removing screws, we're going to need to take off the Wi-Fi antennas. So they go back to the Wi-Fi module here. There's one here and one here. There's little bits of hot glue. Don't worry, the hot glue should just pop off. We'll put hot glue on it again after the repair. Yeah, but as I say, if you're nervous about this, use a bit of alcohol. So with that done now, I can start backing out these screws. I just need to get some tape for when they're all backed out and I lift it up. No, I'll do that afterwards. Yeah, there we go. Alrighty then. So there you go. It looks kind of silly, but it'll do. It means those screws will all kind of stay where they are. But you can, the board should be fairly easy to get out. I think it's just these two screws here, and then it should slide out. So we'll use this one. So yeah, they're kind of unique in size. I'll put those in our little magnetic bowl, and now we should be able to back it out. There we go. So we just need to disconnect one more antenna here. Oh geez, look at this. Anyways, we'll come back to that. This could be interesting. Oh Jesus, could be a no fix. We'll have a look at it anyways. We won't write it off just yet. There we go. I'm not too worried about the rest of the hot glue. Wow, look at that. Yeah, I think that there's actual copper in that. So it's blowing the, I think it's blowing the traces off the board. This could very well be a no fix, but I won't call it yet until we get in close and have a look. Yeah, that's molten copper. You can kind of see it on the cotton bud as well. Yeah, that's insane. Okay, so let me get the actual back of this out of the way. We'll get the board. I'll do a little bit of a clean up here, just to get rid of some of this salt and crap, and we'll have a closer look at the board. So, we're not going to bury the lead here. This is more than likely a no fix. Traces blown copper, kind of molten copper sent flying. But let's zoom in. We can still have a bit of fun. So I've done repairs on these before when they're not so bad. you usually can resurrect them, but this one looks like it's particularly bad. So when I first opened it, and it was hard to see because the camera, but I did straight away see that the traces here were exposed. So two sets of traces run on this side, and there's two more on the other side. Now I've done a repair. If I have a picture, I'll throw it up now. But yeah, I've done a repair where some of these traces and this site here around the actual connector is gone. But what we'll do is, just while we're here for fun, I guess, is we'll check out the transformer. I'll just grab an Ethernet transformer from my spares just to show you what I mean. So this is an Ethernet transformer that came off something else. I'm not sure if this one is shorted or not, but you can see that we have these potted coils with kind of magnet or Kynar wire wrapped around them. The idea being is that the electromagnetic fields isolate one side from the other. So it's a straight DC to DC transformer, but the idea being that you're isolating the port isn't hardwired to the actual circuit, so you're offering some kind of protection to the components on the board. So I'm just going to kind of roughly go down them. No, we checked the transformer, and it actually survived, even though there's smoke and crap everywhere. But what I think happened was, so you can see the traces blown off the board on both sides, but this side is particularly bad. So more than likely, when this got hit by lightning, it was on the port, not on the antenna, which is common. Like that's fairly common. But what happened is it would have traveled up here and hit these guys. Now, you don't really see these all that often, and these are GDTs, gas discharge tubes. They basically act like, how would you put it, surge protection. You only really see them on stuff that's outdoors. You'll see them in marine gear, radios, stuff that's going to be exposed to lightning. So part of the material we seen that was deposited on the actual inside the actual radio and the casing was probably material from these gas discharge tubes erupting. Basically, they would have gone in a split second from the huge current from the lightning strike. Other radios will have like these set up with your TVS diodes, your transient voltage suppression diodes. You see here beside this kind of inductor or choke. That's common enough, but on bigger radios you really do need these. You won't see them like on smaller Ubiquiti gear, even though Ubiquiti stuff, I really like the way it's put together. It's nice circuitry. But on these kind of 5 gigahertz radios, you're going to see that you're going to need these. So that's what saved our transformer here from basically getting absolutely melted. A lot of this discoloration and kind of material is from the gas, the GDTs, the gas discharge tubes. So these are gone, obviously blown. The traces in here are probably fine.
Right.
Or rather, they're not fine. They're blown clean off the board. But I could replace them. That's not a problem. I could restore connectivity between here, replace that transformer, get new GDTs on here, If we flip it over, you can see that these GDTs pretty much survived. Although if I was going to replace if I was going to work on them, I'd replace them all. So yeah, I wouldn't necessarily just replace the two that I know are gone. I'd replace them all. I said earlier on that this is a no fix, and that's quite right for now, and I'll explain that. I have 3 other ones of these radios to repair. And one of the things with these radios is when I'm repairing them is reliability. So once I examine the other 2 and see how they are, I'll make a call and come back to repairing this one, because I know one of them has a faulty Wi-Fi card. So if this Wi-Fi card is working, if that's the only thing wrong with it, then I get a working unit for free for the client, and they're happy to go ahead with that. That's kind of what they intended. Whereas if there's another unit then that also I suspect has lightning damage, and if it's not as bad, or kind of out of those last 2 units, I'll take the best 2 and kind of make one working good unit with it. And then I can finally, once I have those 2 repaired, I'll have this one that I can kind of work on the side. Here's one that I took apart off camera. Now, first of all, you'll notice that there's this salt and kind of moisture ingress into the actual unit. So this is a far easier kind of repair. So let me zoom in a bit. Okay, so we can kind of straight away see the problems we have here. There's some slight burning, I'd imagine, around some of the connections here, the through holes on the actual port itself. This is the fiber port. These aren't really used that often up a mast. This would be connected to a switch, Cat6 down to a switch, PoE switch, and they connect through fiber there. It's way better than having your fiber transformer, or kind of optic to electric kind of coupling here. Your SFP, it's easier to do that down at the switch, so that's not really used. But still, if I were to leave that on the board, it would, think of it as contagion. The corrosion, all this crap here is going to make its way. It's going to continue on up the board, so it has to be gotten rid of. The port inside, yeah, you can see straight away we've discoloration on the pins here. They don't look great, so this is probably going to be an easier repair than the other board. I'll have to block out these numbers but yeah, this will be an easier repair. So what I'll do for this one is we're going to first of all, we're going to remove the SFP cage. There's no need for it. I have spares. I mightn't even put one on because they're never really used. You may use them at ground level for configuration or stuff like that, but generally you do everything over the PoE RJ45. You don't bother really with these SFP ports, but I'll get rid of it. The thing with them as well is they're not generally soldered to the board. You can kind of yank them off. They're just kind of press fit onto these little ground pads. They're more or less just to guide you into the port, so it's easy to connect. But yeah, I'll remove the cage and clean it all up with alcohol. This port will have to come off. I'll have to replace it, and then we'll kind of inspect this area once we get the port off. So that's what we'll do next. We're going to remove the 2 ports. This one I mightn't show on camera because it's literally just a case of getting in between the board and the cage and prying it off. There's no desoldering or anything like that. But this one I'll show on camera how I remove these. What we'll probably start first with is just give it a good clean with alcohol. Okay, so I was just going around the board doing a little bit of cleaning after removing the fibre port cage, and I noticed this area was quite white, but you can see the water, some salt has got up on this, some moisture, and it's actually eaten away one of these resistors by a test pad. Now, you can see what's left of it kind of floating around there. These are more than likely 0 ohm resistors going to these test points. So what I'll do is I'll replace it, but I'll just make sure that it's nice and clean before I do that. Try and remove as much of this stuff as I can. Yeah, it's annoying, but that's just what happens with the weather we get here. I'm sure I don't even need to replace this resistor, to be honest with you. I think it's only necessary for if you're going to use these test points, but I'm not going to be using the test points. But I will clean it up all the same. So wait, I just fire up the iron. So yeah, it might be obvious to you there on the video, but yeah, the pads for that are completely gone. But as I said before, it doesn't really matter because it's just a 0 ohm link for the test pad here, for scoping the board. So I don't know, clocks, something like that. Regardless, I don't think we need it, but it does kind of go to show you like how the salt can really do a job on these. So I'm just going to kind of go around and look for any more kind of areas where we could have problems like that. So what we need to do before we're going to remove this port is we're going to need to flow in some fresh solder. So I just have a biscuit tin underneath it so that after I flow in the solder, when I hit it with hot air, I don't melt my nice mat. As you can see, when we flipped over the board, we seen like, yeah, there was some burning here from the port. I don't think it's anything too bad. So these two through holes go up to the transformer through the GDTs on this side, and because I've repaired these in the past, I know kind of where the other ones are going. What I will do is I'm going to kind of poke around here. I want to see how badly burnt these are. I think it's just, yeah, they're probably okay. So we have some burning or carbonization really between these two. So the problem with that is once it's in use and service again, that could get worse and act like a resistor. There's not much holding that there. Wait, let me just see. I think that's salvageable. This pad. Hold on. So I don't know if I've shown this before. It's a micro grinding tool. I guess I'll get a picture of it and show it on screen rather than having to zoom out. But basically, it's like a tiny rotary tool. You may have seen other repair places using them, but it allows you to grind away material. So what I'll do is I'll try and grind it just here, just to see. I'm just trying to see if that brown is it fiberglass layers or is it just discoloration and wrap on top? The through hole is still there, but the pad is gone. It's not the end of the world. So what I plan to do is I think we're going to have to remove this material here. And once the port is in place, put a jumper wire from this trace somewhere to this pin here. Because it's just, that isn't enough. And I do need to remove that material there. So, yeah, what we'll do is we'll grind out that because I need to get this black material here out. It can't wait there. It needs to go. You can kind of see now what I needed to get rid of this material here because it was just carbon, so it was going to act like it's going to act like a resistor across the two pins and just burn up the first chance anything could happen. One of those things where you can't let the perfect be the enemy of, the good, or the it'll do kind of. Okay, there we go. Is I'm going to get a toothpick and I'm going to try and seal up just this area between these three vias. I can get a drop or two of UV Cure solder mask in there. I'm not too worried about this. One thing I will say is for stuff like this, I generally use like a toothpick. It seems like a better end to use, but I have my craft knife because they're just too fat. Regularly, you've got to sharpen them down to a real fine point. I waste so much of this stuff just getting it out. Alright, that doesn't seem like much, but that could save your ass. Yeah, that solder mask is UV or solder mask is available on eBay, places like that. You'll get it. You'll also get like a little UV torch on there too. And I'm just going to, yeah, I'm going to go away, leave that there, and come back after it's set. I might put another drop on it. Okay, so I hit it with some hot air as well. Actually, leaving the light like that isn't a great idea. You want to have it, because it's too concentrated, you want it to diffuse along all of the surface. So you just get more UV rays this way with it held above rather than sitting on top. But anyways, I digress. I'm going to get another tiny drop and just go over that one more time. If I can, without making a bloody mess, but it's awful hard with this stuff. I don't know what kind of carcinogens are in it. Probably not good for you. Okay. So I just scrape some off the cap. See if we can get some in here without clogging it all up again. Okay, that'll do. I'm not going to do better than that. So I don't know, I use the hot air station to cure this stuff just to heat it up. I don't know if it actually aids in curing it, but in my experience, it goes a little faster. Pretty diddly. We're in the hot air station. So I'm going to let that probably cure overnight. I'm not going to do much else tonight now. It's Friday. I have stuff to do. So I'll pick up from where I left off in the morning. Okay, so it's the following day. Our UV solder mask should have cured when I turn off the crosshair. There we go. So now it's time to patch that trace. So I have a replacement port here. So already you can see there's an issue. The wire, the conductor is going to need to go underneath this. So I have two options. I have Kynar wire, and I also have some 28 gauge stuff here. Kynar would be, how would you put it, neater. My only thing that's kind of turning me off using that is it's not as wide, and it's not going to handle as much current. It's probably going to fail quicker. The two through holes here and this one, I know they don't look great, but they're connected on the other side, so I'm not too worried about those. So what I might do is use some of this 28 gauge stuff. Another advantage to this 28 gauge stuff is the insulation on it is actually really heat resistant. It does mean you've got to strip it fairly well before you use it, because you're not going to get it off that easy with the soldering iron. It just doesn't like to melt like the Kynar wire or the magnet wire. So that's also another reason I'm going to use it. Something like that. And I have plenty of conductor going through on the other side. So we have our wire link now, but before I go any further, what I want to do is kind of secure this down, probably from about here to here. It's soldered, but I just need to seal up this. You've seen how the moisture gets in, so we've got to kind of do something about that. Now, whereas I used UV Cure solder mask around where the, it's going to be exposed to solder and temperature, and I didn't want that. I'm just going to use regular nail polish or nail lacquer, just a kind of a clear coat lacquer, just to go over this joint here to seal it up and stop moisture ingressing. Okay, so I'm going to leave that cure for a while, 10-15 minutes. Go have a cup of tea. We'll attach the port then. Nice. Gonna have the wire excess. Nice. So this should go on real easy. So that is the new port on. What I'll do is I'll just put this to the side. We have one more of these B11s to repair, so I'll test them both at that time. Because testing them right now, I need to, get out the power over Ethernet injector and stuff like that, and probably a laptop to go in over Wi-Fi. But yeah, we'll grab the other board and see what's up with that. This is the third radio. I went ahead and put some tape over the serial numbers. It'll save me having to do some post-processing. But this should be relatively simple. It's missing its Wi-Fi card. It was taken and put in another unit. Fair enough. There was numerous notes left with this one. No power, no RxTX, stuff like that. So what I'm going to do is we'll take the Wi-Fi module from the one that got absolutely knocked by lightning. The first one we had a look at, the Wi-Fi modules should still be fine. But the port here, you may think on a glance it looks fine, but it's got a lot of that. Let's see if I can get it in focus. It's got a lot of whiteness around it. I'm not too happy about that. The actual pins as well. I know it's hard to see with the light there, but they don't look too smart. So I'm going to replace those. Yeah, I'm worried that there's a lot more salt between the port and the board, so I'm going to clean it with a bit of alcohol. I did already give it a good old cleaning, but you can see it's got lots of this salt everywhere, so I'm going to have to like come up with a plan to get rid of more of that. Yeah, salt being alkaline, I might use like a mild acid, like a white vinegar, to get rid of some of it, and then clean the white vinegar off with alcohol. That might be a good idea. Um, just to neutralize as much of it as I can. But for now, what we'll do is we'll take off the PoE port, and we may as well go with the SFP port too. So we are back with L Lightning damaged module or radio, and I need this Wi-Fi card, so we're going to pop that out. It's PCIe, the kind of, I don't know, what would you call it? Like an early generation of PCIe. It's not that fast. And so this is the one we just replaced the port on, that had a kind of saltiness on it, I guess. It'd be like me if this doesn't work, salty. So we're going to pop that in here, but what I'm going to do first is our good old friend contact cleaner from WD-40. We're going to get some of that in there. Okay, so the other antennas are still on it. Anyways, it doesn't matter. I'll whip those off. I should have enough SFP cages for the ones that I fixed as well. So there we go. That's fine. But yeah, so we've transplanted that and got a new port on. So I'm going to leave this to the side. I want to grab the actual part of the housing of the radios just to show you something real quick. I wanted to show you these. So this is the housing. But as you can see, we have all this kind of build up around the place. Now, I need to get rid of this. So the most efficient way to get rid of this would be to bring it to somewhere where they have a sandblasting chamber, where they could clean all this out. But this is probably one of the worst ones. So this isn't quite as bad. So what I'm going to do is I'm going to get a Dremel and a steel with the kind of steel brush attachment, and I'm going to remove all this kind of calcification or salt or kind of whatever this alkaline material is. Get rid of as much of it as I can. The housing from the first unit, I'll do a clean up on that too, because it had very little of this salt buildup. Its major problem was that it actually had copper deposits from where the port had blown. Just to kind of explain, I don't have the ability to capture kind of how to clean up this on camera, but I'll be using a Dremel with a brush attachment. I'll go out somewhere where, you know, I'll wear a mask and goggles and all the rest of it, and I'm just going to kind of use the abrasive brush to just get rid of all this crap. That's probably going to take me the guts of an hour and a half to work on the two radios. So I'm on the mobile phone recording this at the moment just because it's handier. The first unit we worked on, I've tested out and it's up and running. I'll show you the kind of configuration screen there. I might have to blur some stuff out, but yeah, it'll be fine. What I will show you is your IP configuration for that, for people. Wait, I just see. There we go. So that's how you're going to set up your IP address if you want to access the factory reset and configuration over LAN. If you power it up without the LAN cable, you'll have a window of access over wireless. I've found that kind of finicky. You know, a lot of people will sympathize with that. If you have experience with configuring devices over Wi-Fi, it can be hit and miss depending on the setup. The window, it can be quite small, so it's handy to have a LAN set up. So there you go. That's your IP address and the default gateway for the radio. Now, depending on the actual revision of the B11, it depends on the firmware, you mightn't be able to do that. But anyways, there you go. That one's working. I'm going to move on to the second one we repaired now. So as I was recording the testing out the other unit, I was keeping a track on Storm Éowyn.
I am no
man. As it approached, and I was in contact with the client, and they were keen to get the two working radios back, as they rightly suspected that they'd need them because there'd be damage done.
Ireland bore the brunt of Storm Éowyn. Authorities had warned of extremely destructive gusts of wind. Gusts of up to more than 180 kilometers an hour were registered. The winds are the strongest recorded since the Second World War.
So yeah, it just so happened that one of the biggest storms in recent history hit the country, breaking all kinds of records. So I just got my power back last night. So I'm just kind of finishing up this video. But the two units are working, and hopefully it worked out for the client that they had spares. I do expect other clients to come with gear in the next couple of days, because there was extensive damage in the area to electricity networks and in my case communications networks. So I'm expecting radios, switches and other gear to be coming onto my lap, onto my desk fairly soon. It was annoying without the power. I had a generator. I'll show you a little clip of how I kind of once I got a mobile phone signal, how I was able to get around that. So this is my UPS. I get about 45 minutes of power just off the batteries to power the TV, but also my Wi-Fi hotspots and the router connected to those. There's a 4G LTE kind of mobile phone style antenna outside. It's higher gain than your regular mobile phone antennas, so it gives me a good enough internet connection. So when the generator's running, it'll charge the batteries in that and power the other devices. But then once the generator's off, I get about 45 minutes out of that. So yeah, that's how I'm getting online. So I'm only online for maybe 2 or 3 hours a day at the moment. But yeah, that's how it works. But yeah, that's just the reality of living in the west of Ireland. And when you're dealing with this kind of gear, it's important for the networks to have spare equipment, because you know, you're guaranteed at least one storm, maybe not of the magnitude of Éowyn, but you're guaranteed at least a couple of storms every year that are going to do damage. January is usually the kind of danger zone, January, February. But you can get, you know, storms coming in out of the Atlantic anytime here. So it's not how I envisioned the video ending, but that's just the reality of things. I had hoped to show you more of kind of configuration, how to configure the B11s over Wi-Fi, do factory reset, things like that. I just didn't get the chance with how things played out. I'll probably have more kind of this kind of content coming up on the channel. I have more repairs coming in. As you can imagine, after the storm, there's going to be quite a bit of gear that will need fixing. There'll be other Ubiquity stuff and other brand kind of network gear, switches, things like that in the near future. I'll also, the old content hasn't gone away. I'll still be doing like consoles, PCs, gaming stuff in the near future as well. But yeah, definitely not how I thought the video would end. But yeah, I'll be back with more stuff real soon. So cool, folks. Take care. I'll chat to you all again soon.